I mean, I could go on and on. Your team was fantastic. I mean, you were responsive. You worked to perfect the design I gave you instead of working and changing the design that I had to meet the printer, you made the printer meet the design. And that's rare, right? A lot of these companies, because the technology is right on that edge, they usually go to that latter option first. Well, let's change this design and this, and it's going to print better. But additive manufacturing, if we're going to do it right, there should be as little design constraints. I mean, it's right. I mean, that's the end goal here. And yes, you have to design understanding it's going to build in a certain direction. But the B9 team kind of was able to very quickly um, kind of configure the printer to get us what we need. And I remember you guys turned around one set of prints in 24 hours, and I had them at my house. And that helped me make decisions on my company objective and strategy on our go to market timing and strategy and what we're going to do. So that was tenfold faster than every other company I worked with. When I sit and I think about the vision that we have, and we ultimately did not purchase the B9 printer and went with injection molding just because we have to plan for success. We're running out of time and we had to go to high volume quickly. But your team came back with, um, the service team was able to provide a solution. And I think this is something that you had listed as a discussion point, and it's important from a med device standpoint, is that from a regulatory standpoint, the B9 team was able to meet my request of providing 100, 200, 300 parts from the service department in order for me to then treat those as incoming parts. And that's important because we have to get our process up and running. So if we're going to bring this printer in, there's going to be processes, there's going to be IQ, OQ, PQs, there's going to be maintenance. There's a lot of procedures. It's a lot of just fun paperwork in the med device space. And if you can take out the beginning part of that, so the parts come in with a CFC, just a certificate of conformance, it takes a lot of that work out to allow us to start moving in parallel, getting those processes up and running, but also starting to build and doing all of our verification and validation testing on the parts that you gave us that get us to market. And so I'm trying not to use too many buzzwords here, but what it did for us is it allowed us to make this a real opportunity to get from, honestly, napkin to commercial launch in 4 weeks. I mean, this is a class 1 device. So when we get into class 2 with sterilization, there is going to be a whole slew of other hurdles that we would have to overcome with this technology that we just didn't get a chance to get into. And I'm sure there's solutions, but for a class 1 to get from napkin to commercialization and be able to just print these and assemble them, package them, and ship them, that's the holy grail, right? I mean, that's what we're after. And we were ready to do that, other than the fact that we just couldn't get the volume up. That's not to say that in the future, where I do see this going and where UVision and we're a DBA, so our product and our new company name is Luminelle, we will build up a pilot manufacturing line with 2, 3, 4 of these printers. And now you have that volume to start releasing with some real efficiency here, 200, 300, 400, 500 pieces limited launch clinically. I mean, that you'd be able to, the design cycle and the release cycle and the clinical and commercial confirmation timeline shrink by more than 50%. I mean, if you're talking from design to prototyping to building tooling to commercial and then a do loop to do that, you could be talking anywhere from 6 months to 12 months, depending on a simple device. It could go a lot longer than that. With this technology, if you do it right, with as I just described, there's no reason why that doesn't take less than 3 months.